L1 and L2 have these equations. They're vector equations that describe the lines in 3 dimensions. And we're asked to show that L1 and L2 intersect given the position vector of the point of intersection. So we need to show that they intersect. We can't just assume it, but if L1 and L2 intersect, then it must be that they will intersect at like the same, they'll give the same kind of points where they intersect. And so we can find the position vector, and it's going to be when our R is, well, we've got X, Y, Z here. So the X value will be -5 plus 5 lambda for the first line. Then we've got our X, Y, Z for the second line. That is going to have to equal 24 plus 3 mu. We can do that with all of them. Create 3 equations with 2 unknowns, actually. 6 minus 2 lambda is equal to 1 plus mu. 15 minus 2 lambda equals -5 minus 4 mu. So I'm going to solve a pair of these to get a solution for lambda and mu, and then just put it back into the other one to show that it works there as well. If it doesn't, actually it means that they don't intersect. So in fact, I'm going to take the bottom two because we already have the same coefficient here. I'm going to subtract them. That will give me -9 equals 6 plus 5 mu, which means 5 mu equals -15, mu equals -3. Put that back in. So therefore 6 minus 2 lambda is going to equal -2 because it's 1 minus 3, which means 2 lambda is going to equal 8. Lambda is equal to 4. So I've used these two. Maybe I should just, well, I think I've implied it. Okay, so now I'm going to check. So the left-hand side is going to equal -5 plus 20, which gives 15. Right-hand side is equal to 24 minus 9, which is also equal to 15. Therefore, L1 and L2 intersect. Just got to put it back into either one to get the position vector for the intersection. So I'll put it into this one. R is going to equal -5, 6, 15. Then my lambda member is 4, so it's going to be plus 20 minus 8 minus 8, which gives me 15. Actually, I had that one before, -2 and 7. That is my position vector at the point of intersection. On to part 2. We're asked to find the equation of the line which intersects L1 and L2. Remember, we've actually just found out where they intersect. It was at 15 minus 2, 7. And is perpendicular to both, giving our answer in Cartesian form. So we've got the origin, and then we've got, say, line 1 here. Remember, we're working in 3 dimensions, so this is just a little sketch to represent it. And we get onto the line using this vector, and we go in some direction to get to where we want to, and then we times by lambda to get anywhere along the line. The same is going on with L2 over here. Get onto the line, the first vector, and then we go along some with the direction vector, we call it. So now we've got this other line, this purple one, and we're going to get onto the line with this pointer, this point of intersection, or this position vector for the point of intersection. So we just need the direction vector after that. And here's the thing, we know it's perpendicular to both L1 and L2. So we need a vector that's perpendicular to the two direction vectors. So direction vector for perpendicular line. For this, we can do the vector product of the two direction vectors. I, j, k, so this determinant, then 5, minus 2, minus 2, 3, 1, minus 4. So let's expand it along the first row. So it's going to be I, minus 2, minus 2, 1, minus 4. This one's positive because you times by minus 1 to 1 plus 1. The row and the column are both 1. The next one is going to be minus j because it's minus 1 to the 1 plus 2. First row but second column. Then cross this out. We're going to be like, oh, not that bit. Cross this out. 5 minus 2, 3 minus 4. And then back to plus because it's the first row, third column. Minus 1 to the 4 is just 1. Then I've got 5 minus 2, 3, 1. 8 minus minus 2 gives me 10. Then minus 20 plus 6 is minus 14. That's going to become plus 14, the minus. 5 plus 6 is 11. Therefore, R is going to equal this 15 minus 2, 7. That's to get onto the line. Then plus some scalar quantity. We've already used lambda and mu. I actually used beta. I think they use v in the answer. It doesn't really matter. And times 10, 14, and 11. Now that is the vector equation, but we're being asked to write it in Cartesian form. I'm to do quite a lot of work here. So we've actually, remember, got this as x, y, z. And therefore, I can make beta the subject in each case. I'll just do the first one in full. So x is equal to 15 plus 10 beta. And that means beta is going to be x minus 15 over 10. And I can do the same with the y one. So it's going to be y plus 2 over 14 when I make beta the subject in that case. And then finally z minus 7 over 11. I can just get rid of the beta. It's just a scalar quantity, but I've got a relationship between x, y, and z. This is my Cartesian equation.